let's proceed on to multiple angle identities. And now we'll start with double angle identities. But first, let's refresh ourselves with the identities we have established so far. So we have the fundamentals: sine square theta plus cos square theta is equals to 1, 1 plus cot square theta is equals to cosec square theta, and tan square theta plus 1 is equals to sec square theta. Now we have the sum and different identities, but now let's reduce this into 3. Let's combine this into 2, and we'll say this will be sine. Okay, we want to reduce this into 2, so we have sine A plus or minus B is equals to sine A cos B, sine A cos B plus or minus, because we're combining this together, plus or minus cos A sine B. Similarly for cos A plus B and cos A minus B, so that's cos A plus or minus B. We can say that for the positive sign we have negative, and for the negative we'll have positive. So it will be cos A cos B, negative for the positive and positive for the negative, sine A sine B. And finally for the tan, which is tan A plus or minus B, will be equals to tan A plus B is positive for when we have plus, and it is negative when we have negative. So it will be plus or minus tan B divided by 1. It is negative when we have positive, and it is positive when we have negative. Will be tan negative positive of tan A tan B. So we have reduced these 6 expressions now into 3. This serves as the fundamentals, and this serves as the sum and different identities. Now to get the double angles identities, all we are saying in essence is we should look for expressions of sine 2A, cos 2A, and as well as tan 2A. So to establish that, we'll just say that sine 2A is the same thing as saying sine A plus A. So in view of that, we'll just have the formula for sine A plus B. Sine A plus B, according to this, is equals to sine A cos B plus cos A sine B. That's sine A cos B plus cos A sine B. So now if we change this B now to A, wherever we see B, we change it to A. So we have sine A plus A is equals to sine A cos A plus cos A sine B. And this will result into 2 sine A cos A, and which is an expression for sine A plus A, which is equivalent to sine 2A. So we have found the expression for sine 2A to be equals to 2 sine A 2 sine A cos A. So moving on, let's find the expression of cos 2A, which is equivalent to cos A plus A. So we are saying in essence that we have cos A plus A. Let's have the formula for cos A plus B. So from here we have that cos A plus B is equals to cos A cos B minus sine A sine B. So we have cos A cos B minus sine A sine B. So in essence, if we change B to A, that means we are saying we are placing everywhere we see B, we change it to A. So we are saying cos A plus A will be equals to cos A minus sine A sine A, and this will be equivalent to, so we are find cos square A, because cos A multiplied by cos A is cos square A, and sine square A, because sine A multiplied by sine A is equals to sine square A. So this is equivalent to sine A plus B plus A, which is also cos, okay, which is equals to cos 2A. Therefore, we have that cos 2A is equals to cos square A minus sine square A. Now we'll find something interesting here, that we have an expression of cos squared and sine squared. If you recall from the first trigonometric identity that we established using Pythagoras theorem, that sine squared theta plus cos squared theta is equals to 1. Now let's implement that. If we have sine squared theta plus cos squared theta to be equals to 1, then we can have an expression for, let's change it to theta to A, for sine square A plus cos square A to be also be equals to 1. So if we say let's make sine square A solve the formula, we have that sine square A is equals to 1 minus cos square A. If we make cos square A solve the formula, we have cos square A to be equals to 1 minus sine square A. Now we can make this substitution. Let's begin with this. Let's make the substitution of sine square A into this. So we are saying that cos 2A, anywhere we see sine square A, we'll change it to 1 minus cos square A. So it will be equals to cos square A minus 1 minus cos square A, according to the first trigonometric identity. So simplifying this further, we have cos square A minus 1 plus cos square A, and this will be equals to 2 cos square A minus 1, which is an expression of cos 2A. Let's keep this aside. Similarly, if we apply this to this, we will have that cos 2A will be equals to, so anywhere we see cos square A, we change it to 1 minus sine square A. So changing that, we have cos square A now. We'll change this to 1 minus sine square A. So this will have 1 minus sine square A minus sine square A. So let's open the brackets. We'll have 1 minus sine square A minus sine square A. So this will result into 1 minus 2 sine square A, which is an expression for cos 2A. So we can see now that cos 2A has 3 expressions. We have cos A, we have cos 2A is equals to cos square A minus sine square A. We have cos 2A is equals to 2 cos square A minus 1, and cos 2A to be equals to 1 minus 2 cosine square A. So that is for cos 2A. Let's move on to tan 2A. So we have tan 2A to be equals to tan A plus A. So with respect to that, we have tan A plus B to be equals to tan A plus tan B divided by 1 minus tan A tan B. 1 minus tan A multiplied by tan B. Just as we have here. Now we are going to change A to B, or B to A, as the case may be. So wherever we see A, wherever we see B, we change it. So sine A cos A, likewise cos 2A is equals to cos square A minus sine square A, which have the other expressions of 2 cos square A minus 1, and as well as 1 minus 2 sine square A. Similarly, tan 2A is equals to 2 tan A divided by 1 minus tan squared A. Now this is for double angle formula. Let's move on to triple angle formula.